All right, thank you. Good morning or afternoon or evening or whatever time it is where you are. I'm Austin Parker, as mentioned, Director of Open Source at Honeycomb.io. We are an observability tool, and we are a big participant in the OpenTelemetry project, which some of you may have heard of. You can find me on the internet, LinkedIn, link.in/Austin L. Parker. You can email me, austin at honeycomb.io. And if you use Blue Sky, I'm on there as aparker.io. So with that said, I want to get started by talking a little bit about everyone's favorite topic, observability. Now, if you know, if you were at KubeCon, either in Europe or, last year in Salt Lake City, or if you if you throw a rock online these days, you're going to hit someone with a very strong opinion about what observability is and about if this project or this particular strategy or this tool does observability right, or what version of observability it is. I don't really want to talk about that right now because I think that everyone's going to have everyone has different opinions on it. I've got mine. You know, I'm probably biased as someone that's been working in this space for a while and as someone that has been part of the OpenTelemetry project for quite a while. You know, and if none of these words make sense to you right now, don't worry, we'll get to them. But what I want to talk about, what I want to start off with today is not what is observability, but why does observability matter? Like, what is the reason that we care about this topic? A way I like to think about software is you can actually kind of draw this really interesting line in how people over time have changed how we build things. So if you look back, not even into antiquity, but just hundreds of years ago, building stuff was very, very involved and required, you know, a significant amount of effort. We didn't have, you know, just power running everywhere, right? If I wanted to go and I wanted to make bread, then I had a very complex chain of things that I would need. I would have to grow the wheat. I'd have to turn the, wheat through a mill. And then it's like, well, how do we run the mill? Well, we need power. So either people are like manually doing it, or I can, go find some wa running water and build a water wheel to sort of harness that energy and automate things, right? And if I want to move from doing stuff at a small scale, at a local scale, to doing stuff at a big scale, if I want to actually turn my bread making from something that just feeds maybe me and the people around me to something that can feed, a city or a state or a country or the world, then I need to scale. I need to be able to take um, all of the necessary inputs. I need to be able to do them at this very, very fantastic scale. And as a society, we decided that it's actually really inefficient to leave individuals and to leave like small groups and say like, oh, you just have to go do all this yourself, right? You have to provide all this infrastructure yourself. And so the concept of like the utility was developed, right? That we can, as a group, collectively build um, massive amounts of resources, produce massive amounts of resources, and then let people plug into those. So instead of having to go and find a river and build a mill, I can just hook up to the power grid, right? And we can produce power at, we can produce electricity at unfathomable scales. And because of this, we've been able to unlock so much potential, right? We've been able to allow people with good ideas to kind of make those ideas reality by adopting this sort of this utility approach to resources, to the necessary inputs to a system. We've also done this in software, right? Like if you've been in the industry for a while, if you've been building software for a while, think back to the 80s and 90s when the system was a big thing, right? If you were trying to scale your application up, your web-based application up, then you had to go do all this stuff yourself, right? You had a server, and if you wanted to support more users simultaneously, then you need to go get more servers, and you need to plug in a new server, and you're duplicating all of this functionality onto the new server. Maybe you get really, really big, and suddenly you need a lot of servers, so you're building data centers, or you're doing all these sort of things. And I think the real journey of the cloud, the real journey that our industry has gone through with cloud native, is this process of decomposition that I've illustrated here, right? We've gone from thinking of the system as this big monolithic box, and we've started to, you know, zoom in and look at all of the dependencies, all the different parts of the system. And then we can see that those smaller pieces are also systems unto themselves, right? And underpinning all of this is the idea that the people that sort of build and maintain these systems are also super important to them. We can't understand how the system works without also looking at the people that have something to do with either building it, deploying it, writing the code, making sure that pages are responded to, signing the checks for our, cloud spend, or even at a more meta level, right? The people that are, part of this community that are building the things that we build the software on, right? Events like KubeCon, webinars like this one where we can kind of sit and share, ideas and information, right? These are all important things. These all contribute to the system. And saying like, oh, the system is just a bunch of YAML files, or it's some Go code, or it's a bunch of Java, misses that inherent complexity, misses that connectivity that actually makes the system more than just, it is more than the sum of its parts. To illustrate this, I like to think of astronomy, right? I like to think about planets because from a very far distance away, this looks like one thing, right? This planet, it's very pretty, but it's just like a big floating rock in space, right? And we look at the accretion disk around it, and it looks solid from this far out, from millions of miles away. But if you zoom in, and we've seen this, we've proved it, we've sent probes out. If you zoom in, this disk is not solid. It is a collection of, rocks and gas and other things that have accreted into something that looks like a disk, that looks solid, but is actually, the sum of many, many, many tiny parts. And only at a distance does it, if you were standing where that point is, right? If you were standing in the middle of it, you really wouldn't be able to tell because it's so huge, right? If I'm in the middle of that disk, all I see are the individual parts. From far enough away, we see, you know, the emergent sort of properties of the system, and we see that it's like, oh, it's a disk. It's very pretty. Um, how do we do this, right? What is the way that we as people kind of understand that inherent complexity, that inherent, push pull on systems? Well, we use tools. We've always used tools as people to sort of, build things beyond where we can stand. If you think back to what I said a few minutes ago with the idea of, oh, I want to scale up my ability to produce bread. Well, what do we do? Well, we built a tool, right? We built the water wheel. We built ways to harness nature to turn it to our own purposes. And I think one of the most impactful tools throughout history has been the idea of a lever. And the lever is very simple, right? You take, by way of example, you take some sort of flat thing, some sort of stick, flat thing, and then you find something to balance it on, like a phone, and then you use it, and it magnifies, right? The act of doing this, the act of pushing that lever over some pivot actually magnifies the force that one person is able to exert on what's on the other end, right? So if I am trying to move a big rock or lift a big rock, and I just go over and I put my hands on it and I lift, it's not going to work too well. But if I take my stick and I put it under it and I find a little rock to balance it on, and I put all my force down on the top end, then it multiplies the force down here and the rock moves. Cool, right? Like fun little physics fact. But we do this in everything. We do this in software, especially. Things like Kubernetes are levers. Um, it's a lever across a lot of things. It's a lever across our ability to kind of come up together collectively and sort of build this nice abstraction layer over things that you just need to do in the cloud. And observability is also a lever, and it is perhaps the most powerful lever for understanding software systems because it allows us to scale up our ability to understand a system, to understand that complexity, right? To be standing in the middle of the accretion disk and be able to see not only what's around us, but also get that million mile away view. That is what observability is. That's why it's important. It's the thing that lets us actually understand these hugely complex software systems that we're building. Now, 2025, I can't talk to you about software without talking about AI, right? Without the wonderful little sparkle buttons that have appeared across all of our, SaaS platforms and everything else. You know, people there is a range of opinions on AI, right? Like some people think it is the best thing since sliced bread. Some people are very skeptical of it. Um, I'm not here to tell you how to think about AI, but I am here to tell you that AI is also a lever, right? AI is also a way to multiply our force, to multiply individual forces about problems. And so it's really this black swan event, right? I don't want to spend too much time on this because I think, one thing that I thought was really interesting between when I originally wrote these slides and sort of, so I wrote these earlier in the year, and then even in the past, 4 months or whatever, right? Like there's been even more changes. We've moved, I think we're starting to see people step back a little bit from the idea of just like, oh, throw AI, rub a little AI on the problem, right? Just add the chatbot button and you're good. And we're starting to see more movement towards tech, how do I actually integrate AI at sort of a slightly deeper level of my product and of my solution, or how do I really integrate AI into how I work as a developer? And I think that, there are a lot of things that are different about it, right? Like two that I want to call out here is the idea of cost. Obviously everything has a price. And the cloud has certainly, I think, primed the pump for a lot of this. The idea of on demand per minute per second billing, whatever. But if you think about, large language models and how we interact with them over APIs, cost really is like a first order primitive. It is very easy to know, not before you do it, but it's very easy to have that running total of like, how much did this cost you? If anyone has used Claude Code, it's newish, came out in the past couple months, but it's a new, agentic coding assistant from Anthropic. And one thing that I think is fascinating about that is that there's just this little slash command in it. You go in, you tell it, hey, I want to do whatever, and it'll go off and do stuff for you. But you can just type slash cost and it'll show you, hey, this is how much this session has actually cost you in dollars, right? When you close it out, when you end a session, it says, this is how much this cost. That's super interesting, right? We don't normally have I think a lot of people don't really have that. We're not used to dealing with things where cost is that concrete or where cost is like so small that we don't even think about it as sort of like an individualized level, right? We think about it like, oh, the AWS bill is going to be 10 grand this month and it's going to be 11 grand next month. And we don't really know why or how or really care about that little jitter. But you can very easily go into, an AI with using AI, you can see like, oh, fixing this PR costs me $50. Um, well, adding a completely new feature probably cost me $50. Like fixing a bug maybe costs like $2 or 50 cents, right? It depends on the complexity. But it's a super tight part of the system. It's first class. The second thing about AI, I think, is that because it's not deterministic, you know, It's actually a lot harder to measure aggregate experiences because there's going to be differences. Even if you have the temperature of a model set very, very low and you kind of constrain its creativity, the simple way that any two of us on this webinar are going to think about very similar concepts and use different words for them, right? And we've seen there's plenty of studies about this that ask that sending the same concept with different words into an LLM does not always map back to the same outputs. So you have very, very, very high levels of individualized experience. And so it's really hard to rely on things like pre-aggregated metrics or other forms of like pre-aggregation that are actually useful, right? Like at best, you can kind of get to a, was that good? Was that bad? Right? You can get a very binary thumbs up, thumbs down. And what we've seen in the sort of AI world is, a lot of movement towards that. If you've ever heard of Chatbot Arena, um, it's a website you can go to. It's run by Berkeley, the school, and you type in a prompt and it shows you two responses and you pick. You say, this one was better or this one was better, right? Like that's super binary. Um, And now you do that enough and you can get some interesting outcome. You can get some interesting data out of it. You can get some interesting ideas. But if you're thinking about this, from the perspective of like, oh, I have my application and people use my application to file their taxes or to move money around or to put fancy hats on dogs or whatever it is your application does, whatever it is that you are building, because of that, uniqueness, like you probably don't have as big of a sample set, and you certainly don't have, it can be really challenging to say stuff like, oh, here's the normal deterministic path, and then here's the new non-deterministic path, and we're always going to show you two options in the non-deterministic one, and you, user, get to pick which one is better. Like maybe we'll get to that point. I don't think most users would appreciate that. I think most, and a lot of times, the actual AI part, the LLM part, is so abstracted away from like what people are trying to do that those sort of binary decisions aren't even that helpful. We can actually, there's a great example of this already, and it's very large scale recommendation systems, right? It's the sort of recommendation systems that like your Amazons and your Googles or your YouTubes or Netflixes use, where they already have extremely advanced machine learning models and they're so complex that it's very difficult for they're probably not super well understood. We know how the math works, but we're not quite sure how it goes through all the tensors to get to the conclusion. Either way, like what can you actually, users aren't good at evaluating, are these good recommendations or not, right? Like, and maybe they should, and should they be? Should they not be? I don't know. People's preferences change. But if you go into YouTube and you look and it'll pop up like, hey, do you like your what we found for you page? Do you like what you're seeing? Trying to kind of take that and do that at scale, very, very, very challenging. Which leads to, what's the same about like pre and post AI? Well, the thing that still matters is like, are users happy? Because it doesn't, people don't give you a pass. In fact, what I have found is that most users right now actually are severely antagonistic in most cases about like using AI as a cudgel, right? Like if they start seeing things where they don't like it, it's like, the algorithm or stupid AI, right? Like user satisfaction is still paramount when we're thinking about developing products or services or software for people. We haven't really changed the fundamentals here. We're still, even if AI is non-deterministic, but it is at the end of the day, it's just math, and we're still just making API calls. So we can still think of these things as resources. We can still think of user requests as transactions. Most stuff really is the same. It's still cloud native. We're still running it on Kubernetes. We're still running it in the cloud. We're still doing pub sub. We're still doing fan out, fan in. All this stuff still holds. And I think it's important to keep that in mind because yes, AI is don't think of it so much as like AI is throwing out the book and saying like, everything's different now. Think of it more like it's a new thing that we're adding to our Death Star of services, right? It's still a part of a transaction. We still have the same problem of when we're trying to optimize system behavior or trying to track down bugs or trying to improve user experience or improve user happiness or whatever it is we're trying to do, whatever our goal is. I mean, prosaically, maybe our goal is like just doing what we've been told so that we can get promoted, right? Like if your boss tells you like, hey, um, go and do experiments to improve conversion on this by 2%, like doesn't that's your job, right? Like you don't have to want to do things for the betterment of the world. You want to do things because you want to keep working, um, or maybe you are very passionate about A/B testing. I don't know. Either way, the problem is still the problem, and the results are still the results, right? Like you still need to be able to untangle this giant complex system. You still need to be able to view the right data. You still need to be able to view it at the right level of resolution. You still need to be able to view your transactions in context with all the data necessary to really understand them. And that is observability. And the biggest challenge of observability remains people, right? All these different people in an organization are going to have their own distinct, wants, needs, competing desires. Your app devs, your platform teams, your central IT, right? Everyone needs something slightly different. And they all have their own priorities. And a lot of times those priorities are, in conflict with each other because well, we keep adding new stuff, right? We keep making systems more complex. AI, if you have done some vibe coding, if you have just like sat down in front of Cursor or whatever and said, "Hey, write this thing for me," you know that it's very possible to have AI coding assistants produce running code. Is it good code? That's a very different question. So we're seeing AI be this huge force multiplier, this lever, right, that is able to allow an individual to do more than they have before. But the trade-off there is that just means more stuff is running in prod. That means we have more telemetry data that we need to collect about what our systems are doing, about what all these new services are doing. Because AI makes it so easy to do this sort of refactor or rewrite or add code, um, more code in more places, more things to keep track of. And I think this is where the rubber meets the road for a lot of people, right? Like the old way doesn't work. The old way gives you this exponential cost curve for observability where every new thing you're adding is a multiplier rather than a linear growth. And at a certain point, that the combinatorics of complexity plus the cost of understanding what's going on does wind up deadlocking the system of people responsible for, running a business, right? For writing code. One thing I don't think I talk about it in this, but I talk about it some other times. This idea that like engineering is often seen as a cost center rather than as, what it is, which is an innovation center. And that sounds really pithy, and it kind of is. But our job as engineers is to build things, right? Like your job, if you're a CTO or you're a director or you're an engineering manager, like it's not to be this expense that just is kind of this constant slow drain that we have to put up with because that's how, the business makes money or whatever. It's like, no, we're supposed to be innovating. We're supposed to be making things. We're supposed to be building things that scale so that we can help other people achieve their goals. And this out of control complexity cripples that. And it puts us into survival mode and it puts us into, oh, we need to start like really cracking down on like how much we spend on our observability bill or on our cloud resources, or we need to reduce our logging or whatever it is, right? Observability, I think, can help us kind of square this circle. It can help center engineering as like an innovation center rather than as a cost center. So let's build a new model, right? Let's think, hey, what is observability? Observability is a way that we understand systems. Simple as that. It's a way that we collect a lot of data and process it, refine it, query it, do all these sort of things to it, so that we can understand what's going on in our systems. And to build this model, we need to understand that everything has trade-offs, right? Observability fundamentally is about trading between sort of these three things that I'll talk about in a moment. And everyone's trade-offs, like if you remember my list of people, my app devs, my platform teams, my central IT, those people all have different priorities. Their trade-offs are going to be different as well. There is no magic bullet. There's no one size fits all observability approach. There are principles and practices that you can follow that will, certainly help you a lot and certainly make it easier for you to, deal with this. But if someone comes to you and says like, "Oh, here, you just do this one thing. All you got to do is this one thing," I do not think those people are being very honest with themselves or you. Fundamentally, there's kind of three things you're trading off when you're building out observability. You're trading between how fast can you like find stuff, how much data do you have, and how long does it take for you to kind of adjust those other two things? So when we think about query speed, we're talking about what it sounds like, right? Like how long does it take? Like when I actually say, "Hey, find all the stuff about the thing," how long does it take for your system, your observability system, to kind of give you an answer back? And resolution is like how fine-grained is the data that you have, right? So if you think about a very metrics, like if you're using a lot of Prometheus and a very metrics heavy observability system, then you probably, your resolution in some ways are very high. So Prometheus makes it really easy to kind of like keep high quality metrics with high precision. And so you can actually have this like really great resolution of like what exactly was the memory doing across all these different Kates nodes, minute by minute over the past, year or whatever. Super high resolution. But what if I want to go deeper than that, right? I want to see that broken down by customer ID or by deployment version or Git SHA or whatever, and I want to start introducing high cardinality data. Well, that's when we kind of start talking about availability, right? The availability of metadata, the availability of dimensions, and the cardinality of those dimensions to let us really inspect, like to really have a deeper understanding of what's going on in our system. The higher your availability, there's a trade-off with resolution or there's a trade-off with query speed. So this is what I mean by there being no one answer. Because if you just put your puck in the middle here and you say like, well, I'm gonna go completely mid on all of this, it works, right? But your queries are kind of slow. They're not especially fast. You have some of this high resolution data, but not really enough, not all that you want at all times. And you've got most of the sort of metadata and other fields you need, but there's stuff that you're missing that you have to throw away or that you have to like sample out. Um, hmm. So we make trade-offs, right? We push stuff around to try and help this. And I think the way you know, I don't know if we'll ever, just to go back, like I don't know if we'll ever actually get to something that's perfect on all of these, right? Like I think there's things that we can do as an industry and as like people working in observability to get us closer. So instead of just like a puck that you're kind of moving around here, you think of it more like it's expanding and you're filling up and eventually you do get to these sort of boundaries. I think the trade-offs always exist though, right? And I think that you can't solve for those trade-offs. You can't really get down into the depths about like how do you really tackle them without starting from the bottom and thinking about the actual raw telemetry itself. So this is why, you know, let's get back to the beginning here. This is why I work on OpenTelemetry. OpenTelemetry is a CNCF project. It's in incubation right now. You've probably heard of it. It's the second biggest project in the CNCF. It is an open source framework for how to define um, telemetry data about cloud native systems. And it doesn't just give you, you know, metrics, logs, and traces, right? It does that. Like it is a standard way to kind of define and create and send metrics, logs, and traces is definitely that. But it also has this idea of semantic conventions. And semantic conventions are a standard way to describe what telemetry is, right? It's a standard way to say, if I have an HTTP server, this is the telemetry data it emits. And these are all the attributes on it, right? And they're consistent across cloud providers, across HTTP server implementations, across everything. So it's a standard way to sort of represent that data, which is really important. Um, the second important thing about OpenTelemetry is that it doesn't, we talk about metrics, logs, and traces, and a lot of people look at it and say, oh, well, it has metrics and logs and traces, so it's three pillars. But I would urge you to look a little deeper because all of those things are actually built on this common context layer. And the idea with context is that everything in OTel is connected to everything else in OTel. So when you create a metric or a log or a trace or a profile or whatever, or a user analytic event, right? That gets connected to everything going on. It all gets tied back to the transaction that it happened on. So when you have your, you know, pop open your phone and you go and you're like, I need a new widget. And you click checkout, that checkout is a transaction. We but it's thousands of other things are happening during it. OTel makes it possible to sort of correlate all that data back to that specific checkout for that specific user, which is because we build on distributed tracing, right? It's like sort of the foundational part of OTel, but we tie everything back to it, which is really cool. And the third thing about OTel that I think helps address these sort of trade-offs is that if you have been doing this for a while, then you think about observability, and you often think about agents. You often think about like, oh, I get observability because I go and I install some proprietary agent that does all this stuff for me. It creates metrics and logs and trade. It does all this stuff, and I don't have to think about it. But someone else has to, right? Like the people making that agent have to think about all that. So the idea with OTel is that we want to actually push this down. We want to shift it left. We want to push it into the lower level, into the language library, into the languages, into the frameworks, into the actual dependencies that you are building software on so that there's no more agents, right? So that you just have this data kind of by default, and your developers and you are able to plug into this substrate of OTel, which is also really nice because it means that like all of the like, oh, we have to pick a logging framework or we have to pick a metric thing, like that goes away, right? You just use OTel. It's great. And I think it's super interesting when you tie it to AI. Um, Speaking personally, because I've been working like this year, I've been working a lot with AI to kind of better understand it, and I've mostly been focusing on like um building stuff with AI, right? Like how are AI coding assistants part of, you know, the profession of being a software developer? And what I found is like several really interesting things. One side of it is that AI observability, understanding what the AI is doing is really challenging. And the fascinating thing about that is that it's also kind of the first big wave in tech that is concomitant with OpenTelemetry. So what we're seeing all these Gen AI companies and all these people working in the generative AI space, like coming into OTel and saying like, yes, we want to be a part of this. We want observability too. And so it's not only is it maybe the first like post-cloud, cost as a primitive technological wave, it's also the first observability centric, right? Observability is a primitive in a lot of Gen AI stuff, which I think is really cool. And we as a project are working a lot with that community right now, right? Trying to build in support for OTel into, everything from the client libraries to the actual like training and pre-training of large language models, into sort of the middlewares of it. So if you've ever heard of the Model Context Protocol, it's a way to connect LLMs to other tools, you know. that's going to support OpenTelemetry out of the box, right? So you'll just be able to kind of get OTel data about what your tools are doing, which is really neat. I've also found that, kind of these last points here about, the amount of code that AI is writing and what you can do as AI assistants, being able to kind of have those standards is so important when you're thinking about AI and AI observability, because having the standards means that you can give those standards to a language model. You can put them in your agent context and say, hey, here's how to here's the guidance on how an HTTP server should be instrumented for OTel. Here's my current HTTP server, right? Here's my current service. Normalize this, right? Like take what you know about OTel based on this document and go over and like improve my instrumentation quality, right? Improve my telemetry data based on this. And we have hundreds and thousands of people a month contributing to OTel and building these standards and creating them in a way that is actually super accessible to AIs because it's all just like YAML and Markdown, right? So it's very easy to go like if you want to try this out for yourself, you can, a lot of this stuff is free or cheap at least. Like go to the OpenTelemetry GitHub, go to semantic conventions, find something like the HTTP semantic conventions, and then just say like, and then tell Claude or Copilot or whatever, like, hey, I want you to write an HTTP, here's the docs for OpenTelemetry, here's the semantic conventions for Gen AI, for HTTP, like re-instrument my existing HTTP server based on this. And it does a really good job. It does a surprisingly good job actually, which is a nice way to kind of get around the whole like, oh, OpenTelemetry is so complicated. Well, just make the AI do it. But I really am a pretty firm believer that this stuff is going to dramatically change how we build software going forward, right? It's not going to replace humans. I think there will always be a role for humans because the AI doesn't, AIs don't know things, they're just math. And it's a skill to use them, but it reduces so much toil for like I have not written GitHub Actions YAML in like 6 months now because I just have the AI do it. It's great. And no matter how much AI we get and we run on our various problems, like our goals are still our goals. Like that, like we haven't fundamentally broken the rules of reality here, right? Like in complex systems, change is a constant. We have to manage that change. We have to be able to understand, like one thing that AIs are actually really, really bad at is anomaly detection. Now, they're good at actually saying, "Oh, this is different than that," right? Like they're very good at actually seeing the distinction. And a fun trick is it's actually a lot more efficient to give an AI like mental question for yourself. If you have a query, you have query data. So you have a time, you do some sort of PromQL or whatever query, and you have two options for how to give that data to a large language model. One option is to give it like the JSON representation, the textual representation of the query results. So you give it a bunch of points in JSON format, or you give it a picture. Which of those is the best way to have the LLM figure out what the anomalies are? If you guessed picture, you were correct because it's actually better at looking at the picture and seeing that there's a weird spike over here than it is at processing the JSON, right? Just because of the way these models work, which I think is super cool. Um, but it doesn't know anything, right? It doesn't know why there's a spike. It just sees there's a spike. And if you blindly ask the AI, like, hey, find anomalies, it'll find anomalies and it'll tell you about them all day long. But it doesn't know, oh, that's a good, that should have happened, right? Like that happened because we deployed a new version and we had, that caused this drain, or we got mentioned on the news, and so we got a lot of people came in to our website, or we got slash dotted is probably a reference that does not play in 2025. We got hacker newsed. I don't know. and this is my point about understanding difference, right? Like human beings are still are AIs are good at like looking at change and seeing if there was a change. Humans are good at understanding why that change happened. And so I think this is the loop, right? We have the AI to help us, find these hypotheses and go through all this data, but we are still in the loop. We are still in control, understanding why that difference happened. And I think the amount of rapid change and innovation happening in this is why we have to think about flexibility, right? We have to build on top of open source. We have to build on things like OTel because if we do rely on these proprietary tools or proprietary agents, then things are going to wear down, things are going to break. There's going to be some innovation over here that we really want to that we really want to pile into, but we can't because we're stuck on the proprietary thing. So again, open telemetry, great way to sort of future-proof yourself. Um, and something that I've heard a lot from people, especially outside the US, is people are very interested in data sovereignty these days for reasons. So that's another thing to think about. And finally, customers like user outcomes matter, right? Like if people aren't happy, I mean the old Honeycomb adage is nines don't matter if users aren't happy. And I think that is still true, right? You can put all the great dashboards up and all the vanity metrics you want in the world, but what really matters and what really gets you, you know, what really actually matters at the end of the day is like are users happy is with how things are working. And that is something that ultimately the AI can't tell you. The only thing it can tell you that is like talking to people and collecting that sort of feedback. So with that, we have, I think, 7 minutes for questions. That sound right?
Yes, we have about 7 minutes, unless we have a lot of questions, then we can definitely hang on a little bit longer. But yeah, if anyone has any questions for Austin, please drop them in the Q&A box at the bottom of your screen.
Yeah. Or if there's anything you want me to talk more about, or yeah, I have the Q&A panel open right here. Augusto asked, what way is it possible to make native telemetry instead of using agents? So in OpenTelemetry, you can import the OpenTelemetry API into your software, or you can use libraries and frameworks that are already have native OpenTelemetry support. So one example of this is um, just to pick something. C Sharp, for example, has like native OpenTelemetry support. So if you use the system.diagnostics library on the back end, that is actually OpenTelemetry. So you just configure OpenTelemetry when you initialize your application, and you kind of just get this telemetry for free, right? Or at least like you don't have to put an agent in. The telemetry is just there. If you're in the JavaScript world, there's this newish JavaScript runtime or Node.js runtime called Dino, and in a recent update, they added native OTel support. So you pass in a config line, like when you start up Dino, you pass in a config flag, and it initializes an OpenTelemetry SDK for you, and then you as a developer write against the OpenTelemetry API, or you use libraries that are instrumented with the OpenTelemetry API, it speaks to that OpenTelemetry SDK, and you get native telemetry without having to use an agent or third-party instrumentations. The support for this varies, like across languages, across a lot of things. For stuff that doesn't have that, then OpenTelemetry has a lot of instrumentation packages that will sort of bridge the gap. So Spring is a very popular one in Java. Like there is a Java agent for OTel that we distribute and support that will give you, a lot of instrumentation out of the box. But the future is definitely like this stuff is going to be built in. Any other questions? And I hope that answered your question, by the way. If not, you can always reach out to me over email. No problem. Um, If applications have to be written, will we do existing apps that do not comply with OpenTelemetry? That is a great question. So there's kind of three things here. One is that for stuff where um, there's three different ways to kind of tackle this. One is that OpenTelemetry is designed to be very composable, so you can write like a little translation layer. Like if you already are using some legacy or some existing um, telemetry API, then either we already provide a bridge or you can write a little bridge to kind of like connect that API up to the OTel SDK. Um, a really popular example of this is something we kind of have like first class support for is logging. So if you look at like our Java implementations, there's a log bridge where you basically add the OpenTelemetry SDK as a sink for your existing like log4j API calls, and we let you plumb that all through. The second thing is you can use our our compatibility packages, right? So we have an agent or we have agents that you can install into like a Java app or a Node.js or Python or whatever that will act like a traditional agent, right? So if you use like a Datadog or New Relic or something like that, where there's an agent that does all this stuff for you, like we do have support for that and we're going to support that probably forever, right? Because it's going to take so long for everyone to kind of update to native telemetry. There's always going to be people that are kind of like not there yet. So we do have a agent-based solution for that. So you can drop in that agent and it will do normal agent stuff for you. The third thing is maybe a little bit forward-looking, but we're working on ways to kind of do this without getting into the user land at all, right? So we're looking at technologies like eBPF um, to allow for runtime instrumentation without actually going in and, you know, doing monkey patching or bytecode manipulation or whatever. And we're also looking at pairing that with continuous system level profiling to kind of give you a best of both worlds. So you get profiling for sort of like function and code level insights, and then pair that with eBPF based instrumentation to get, kind of the connections between services in a distributed system, and then send all that out, and then analysis tools can kind of expect that. So that's I actually feel like a lot of this will eventually wind up there, like where that eBPF plus profiling takes over or becomes like a very, very common thing. Um, especially I think there will always be a place for sort of like user land instrumentation and API calls because you always have stuff in your code that you want to be able to get out through whatever, right? So like there's things that you can't really get at the kernel level. There's things that are really hard to make sense of at the like the profile level. It's like too fine grained. So the idea of just like traces always going to be useful. But what I think we'll see is you'll be able to write against this very thin API layer in your code and say like, oh, well, here's the attributes like customer ID. Here's like the business logic that I care about. I can annotate that in my code and then have it connected to these eBPF traces through various mechanisms. So that stuff is a little further out, like that's, in the future. Today, you can either natively instrument or you can use the agents. Um, and I would actually put the OTel agents up against, most like certainly for languages like Java, they're very good. They're well supported, performant. I would put them up against anything else out there. Oh, and the secret bonus fourth option is you can just do it. You can just like use AI. You can just tell an AI, "Hey, go update this existing app to work with Hotel," and it is a little bit of care and feeding. I'm making it sound easier than it is in practice, but it does a surprisingly good job. eBPF. Yeah, like the eBPF stuff is our goal is to have like a sort of a drop-in eBPF distribution that kind of does this. Like we want to make it pretty easy for people to use. We don't like we have some of it, right? Like we actually have like four separate eBPF things in OTel right now, which is a pain. So we're trying to kind of normalize that and have like one thing that you can use, which would help. But yeah, the idea is we want to be able to provide like a pretty simple eBPF based option to give you um, high quality telemetry about existing apps. Another for Augusto. So I actually think it is like we focus right now on sort of system performance, but it is certainly not limited to that. So I personally am a very big fan of people that add like business metrics or UI stuff into their OTel data. We are in the middle of trying to standardize some of that stuff, like being able to provide standard ways to represent like UI events, front end, mobile, desktop clients, whatever. That's work in progress. And if any of this sounds interesting and you would like to get involved, please check out our website, OpenTelemetry.io, or our GitHub, our community GitHub, github.com/open-telemetry/community, which has links to all the things I'm talking about. But yeah, like we want to be able to like we actually think it's really important to be able to kind of like co-locate your sort of analytics and business metrics and UI stuff with your like persistent performance, right? So that you can see the relationship. Um, I think one of the big challenges right now in the industry is that people look at these things sort of separate, like the business analytics people are over here in Mode or whatever, or in Power BI, and then the like DevOps people are over here in Jaeger and Prometheus, and like ne'er shall the twain meet. But it would actually be really helpful and cool to be able to ask questions like, well, hey, was there like we saw this weird dip in conversions or signups? Could that be related to something in like the system side rather than just having to do like manual sort of like look at this graph, look at that graph, right? So OTel actually makes that possible. Um, and there's nothing preventing you from kind of doing this today yourself, but we want to make that a lot easier and kind of like, yeah, we want to make that easier and make it and be more opinionated about how you should do that. Any other questions? Going once, going twice. All right. Well, thank you all for coming. I'm going to throw back over to Candace to wrap us up today. And again, if you would like to learn more about OpenTelemetry, be sure to check out the OpenTelemetry website at opentelemetry.io. If you'd like to learn more about Honeycomb, check us out at honeycomb.io. Thank you for coming, and Candace, take it away.
Thank you so much, Austin, for your time today. And thank you, everyone, for joining us. As a reminder, this recording will be on the Linux Foundation's YouTube page later today. We hope you join us for future webinars and have a wonderful day.